I'm going to tell you a story about my journey towards my PhD, and hopefully it's going to shed some light on what the process actually is from possibly a very academic perspective of an organic chemist. So, a very brief introduction of myself. So I'm a final year doctoral candidate in the Burton group at University of Oxford. My field of research concerns synthetic organic chemistry with a particular focus on using oxonium ions to make natural products. But fear not, I'm not going to overwhelm you with chemistry today. It will be more about my personal experience, my thought processes, and what I figure out during my journey towards my PhD. So, the first question is, so how did I actually get into organic chemistry? So, what are the reagents and conditions that actually transform the old SAM into the SAM nowadays? It actually all started with the first set of experiments in university. And you think that is another scientific story of me walking into a lab and being completely mesmerized with all sorts of chemical equipments and things. Unfortunately, you're mistaken. The first set of experiments wasn't actually done in a lab. It was just basically an experiment to see whether I prefer biochemistry or chemistry. So, basically, after 2 semesters of biochemistry lectures, it was a really sluggish reaction, I would say. I didn't really change much except for having a few more question marks on my head. But for chemistry, after 2 semesters of lecture, you can see basically my head become benzene ring. So some reaction have happened. And to further catalyze the process, at that time I was invited to apply for a summer research fellowship. So it eventually allowed me to work in an organic chemistry lab for 3 months under the supervision of Professor Pauline Chiu, who works here at Hong Kong U, and with my mentor, Dr. Diana Chen as well. And it basically just completely transformed me into an organic chemistry person. And at the time, I thought, well, synthetic chemistry is great fun, and doing research seems to be a good idea. And this is actually how I got into organic chemistry, and this is also the moment when I had the first idea of thinking about doing a PhD. So, I knew that it's not going to be easy to do a PhD, and at that time, to be honest, I don't really have a very clear idea of how should I prepare for my PhD. So I asked myself several questions. The first one is, how much should I know beforehand? How much should I know before I actually do a PhD? So from my summer research experience, it seems that from my observation, we need to have a lot of original ideas to solve research problems. And what I thought was, if you want to have original ideas, usually they come from novel combinations of existing knowledge. But at the same time, I'm also aware that I really don't know much about chemistry at that time. So what I did was basically to enroll in all the chemistry courses that I could, particularly the advanced ones, and at the same time, start reading journal articles as well. But soon, I realized that there are way more that I could read than I could actually handle. So what I did was to be picky. I just choose what really interests me to read. Second question is about overseas experience. This is twofold. So the first was about my general curiosity in knowing whether people think about chemistry differently if they're educated differently in elsewhere. And another thing is to see if I should try to obtain like preliminary overseas experience if I eventually want to do a PhD overseas, because I actually have to get prepared and to have a taste of what it is like. But anyway, I thought, well, spending some time overseas possibly is a good idea. So I get ambitious and I apply for the HSBC Overseas Scholarship, which fortunately worked out, and then it enabled me to read undergrad chemistry for a year at University of Oxford. And basically it's during this year that actually sparked my interest in actually doing a PhD overseas. Right, and then after this period, I returned to Hong Kong to continue with my undergrad degree as a final year student. And the first question that I had in my mind was, should I really do a final year project? In the end, I did a final year project. And honestly, I would recommend everyone to do it if you are going to do a PhD afterwards. Fundamentally, it's because you will get way more laboratory experience, and then you get lots of transferable skills such as project management, and how to write a thesis, how to do presentations, and how to communicate your science with people. So overall, it's a very beneficial experience. I would highly recommend everyone to do it if you're really going to go for postgraduate studies. And the next thing I thought about was the field and topic of doctoral research. So basically, it's like, which field and topic should I pick? There's so many things to pick out there in the field. And I had a struggle between picking things from a more traditional field, which is basically I'm working on right now, or should I pick things that are more modern and interdisciplinary? And should I actually work on hot topics as well? But in the end, I settled on a very simple solution. I just picked what I love and enjoy to do. And then after this, having a general idea of what I'm going to pick, then I have to choose a school, a supervisor, and a project. And this, I think, is a very complex issue because there are a lot of possible combinations of these things. So the first one, you have a great school, reputable supervisor, interesting project. Basically, it's the ideal choice for everyone. But at the same time, it's going to be very competitive. The second one, you have a great school, but a notorious supervisor, but at the same time, interesting project. The caution about this is, do you know what notorious actually means? For example, if someone says, oh, the supervisor actually pushes students to work very much, but at the same time, if a person doesn't really care to work an extra mile to get things done, that may actually not be too notorious for you. So you really have to get to know your potential supervisor. The third one is like this. It's a medical school, but you have a reputable supervisor and an interesting project. But by mediocre, I don't really mean it in a negative way. It's more like, to be honest, there are some schools that have way better support and facilities than other schools. So what happens if it is in this case that you have a reputable supervisor in a school that doesn't have as much support and facilities, but they're still doing world-class research and is willing to give you an interesting project too? So what is the implication of this? And you have to really think about it. The fourth one is about great school, reputable supervisor, but a boring project. This seems really ridiculous, but this could happen if you do not do your research well and just try to follow what people do, for example, just follow a hot topic and then go into a research program and then realize that, oh man, I'm not really interested in that. And that could be a scenario, and that could be quite dangerous. Or you can have even more fancy combinations of like great school, but a less famous supervisor, but very interesting project. So there are lots of things to do, and the bottom line is you really have to do your own research about your school, your supervisor, and potentially your project as well. And aside from these things, you may also want to look at the academic pedigree of your potential supervisor, because that could be actually quite helpful if you want to continue further studies after your PhD for a postdoc, whatever, because having a connection makes things just way easier. And lab culture is a very important thing as well, because in the end, you're going to work there for like 3 to 4 years. If you kind of blend in, it's going to just not be a very enjoyable experience for you as well. And then after this, it's about funding, it's about money issue. So I'm just going to talk about this briefly here. So this is basically what Oxford offers for organic chemists. So basically there are 3 categories of scholarship: university scholarships, doctoral training programs, and then external scholarships. So for university scholarships, basically, for example, for Clarendon scholarship, those are automatically considered. So when you submit your PhD application, these things go automatically. For doctoral training programs, it's more like a package where you have 4 years of lectures, research programs, and industry engagement. But then, of course, it requires interviews, and it does not have a lot of places, so it's quite competitive. And for external scholarships, which is what I went for example, in a closure doctoral scholarship, you, of course, requires interviews, and then you have to prepare a research proposal beforehand. Right, so now having the doctoral project set and the funding settled, my PhD journey began. So here's the timeline, and here's the boundary. So basically, this actually limits of how long I should be able to, I should be doing my doctoral research. So the targets of my doctoral research concerns the synthesis of 4 oxonium ions and 16 natural products. And I believe no one knows what it actually means. And even if I give you the picture, no one still knows what it actually means. But it doesn't really matter. This is just a general idea to show you what kind of things I have to do. Basically, it's just many things. And to do these many things, the first thing is to synthesize something that is simpler. But that was not an easy task to do. Basically, this molecule has been tried to be synthesized by 2 master students, but unfortunately, those attempts were to no avail. So in the end, did I do it? I did it after like 8 months of my PhD. But did I actually use 8 months to synthesize this molecule? Not really. The idea that actually came to fruition came up in March. So basically, for the whole development, it's more like 3 months. But then what about these 5 months of like pure stagnation, and basically there's no research output? Was it a waste of time? It was actually not a waste of time, and it was actually the period that I made the most progress as a chemistry in training. Because when things do not work, you just cannot stick on the same idea. You just have to think about new ideas, you have to be open-minded, and at the same time, the more you try, the more you get hold of your limitation as an experimentalist. And then for your next idea, it will get closer to how nature behaves, I would say, because we have a saying in the lab, it's like, if you are going across this period, you're actually being humbled by nature, and it's just going to make you a better chemist. And after passing this barrier, I basically welcomed my first 3 natural products in my life, like 1 year after I've started my PhD, and then a few more months of work, the first 2 oxonium ions, and then basically at this time I hit another barrier because for all the methodologies that I have developed previously, they will not allow me to access the rest of the things. So I basically have to go back to the drawing board and then have another 5 months of stagnation before I actually came up to another solution to unify everything and to synthesize the rest of the molecules as well. So once you get things working, then you just have to exploit them. So you just make more molecules, make more oxonium ions, and basically, like after almost 2 years in my PhD, I'm almost halfway through my doctoral project, and then you just have to work harder to generate more natural products. And then basically, you will also come across a situation where there are always something that you really want to do, but nature just doesn't allow you to do so. For example, there are 2 natural products that never really show up despite how hard we try. So what we do is just that we digress. We just find something that is also related to the original project, but was not on the original proposal, and then we try to synthesize it and see if they will work as well. So in the end, in April of this year, basically, this concludes my PhD project with 4 oxonium ions and 18 natural products. If you wonder what I've been doing afterwards, basically I've been repeating crucial experiments to make sure that things do work. It's not like a one-shot experiment and it never works again. And then at the same time to try to work on some side projects as well. So in conclusion, for my 3 years of experimental journey, it's more like 1,000 experiments, and for working hours, basically, I work, if it's daily, then it's from 9 to 10, and I do not have a fixed time to go home, because to me, I kind of plan my schedule around chemistry. So I want to do these kind of things in one day, and I will finish them, and then I go home. It's not like, oh, I have to leave at 5, and then I leave at 5. So basically, sometimes I leave at 5, sometimes I leave at 8 or 9. And then for weekends, it really depends if it's worth it to like spend 5 or 6 hours on a Saturday to make your life easier next week, then it's very worth it to work on the weekends. But if otherwise, it's not too much. And then work-life balance is also very crucial. So basically, I took 6 weeks off a year just for vacation, and then try to relax a bit aside from doing experimental work. So you can see, a PhD journey isn't really smooth. So it is, for me, it's an intercalation of periods of stagnation and periods of growth. And then afterwards, it comes to thesis writing. And the way I do it, and if you have ever wondered, so how do people write PhD thesis? How is it possible to like organize 3 years worth of work in such a short period of time? For me, I tend to write detailed report every 3 months with all the characterization. So when I write my thesis, I just combine all the small reports I have with a little bit of like connections between them. It makes life way easier. And then my oral defense will be scheduled in spring 2019. And then afterwards, if everything works fine, if my fellowship got approved, then I will be working as a postdoc on organometallic chemistry in fall 2019. So to wrap up, so how did I choose my field of research? It's all based on passion and enjoyment. And how did I prepare for my PhD? Unfortunately, in order to do PhD research, you have to do quite a lot of research beforehand. And how was my PhD like? It's an intercalation of stagnation and progress. It's more about embracing failure than just to hope for success. So in the end, I would like to thank the committee for inviting me over to give a talk. And I would like to thank my supervisor, John Burton, and my group members for making me a very happy times at Oxford, and I would thank the Culture Foundation for supporting my doctoral studies. And thank you all for your attention. I will be happy to take any questions from the audience.
Thanks, Sam. Do we have any question from the audience? In the middle? Yes.
Hi, thank you for your sharing, and I really want to know more about during your undergraduate. I think you got a chance to be visiting students in Oxford. Is that correct? Yeah, I want to know more about that experience because I'm also considering doing that, and I want to know how this year inspired you to continue your study in Oxford. Thank you.
So which exact aspects of the visiting studentship you're looking to?
I just wonder how it inspired you to continue your pursuit in your further study in Oxford, and how it's been maybe the studying system and stuff like that.
So basically, the time when I was in Oxford as a visiting student, so basically we have something called a tutorial system. So basically every week you meet with like 3 or 4 supervisors in a small group. So basically you just discuss chemistry in a very lively scenario, and that basically, because that's basically very different from what I have experienced in Hong Kong, and I thought it's a really thought-provoking experience, and that's the main thing that actually attracts me to try to pursue postgraduate study at Oxford, because a lot of times, if you like chat with your friends, basically they're so happy to chat chemistry with you. So basically, it's more like the environment and the students that attracts me there. That's of course one factor. Yeah. And another factor is basically my supervisor gave me a very good project there, and basically it's the project and then the students and the environment that attracts me to go there. Oops.
Thank you, Sam, for your presentation. As a chemistry student from Oxford,
Yeah.
please may I ask, under what criteria are the, how do people decide how much of the chemicals that you will need to synthesize in order to obtain a PhD degree?
So basically, basically there's no standard, because what I thought is like a PhD is very different to standardize a PhDs, because some people, if you know, it works on photosynthesis. Basically, some cannot even synthesize one natural product. It also depends on how difficult the molecule is. Right. So I think it is more like, in the end, how much you have tried and how much you have demonstrated your intellectual capacity. That would depend on how you would get a doctorate or not. That's what I think. Yeah, that's what I think. You don't really have to synthesize 18 to get a doctorate. Yeah.
Okay, cool. Let's thank Sam.